In this video, we will explore the fundamental concept of vectors. This includes vector notation, representation, types, and operations. A vector is a mathematical entity that has both magnitude and direction. Vectors are typically represented using an arrow, with its head representing the direction and the length representing the magnitude. They are denoted like this, with an arrow on top to represent which way are we going. It's important to note that the vector AB is not equal to the vector BA. Instead, AB equals negative BA. Let's take a look at an example. Here we have vector OA. We write vectors as x, y, where x is the horizontal displacement and y is the vertical displacement. For this vector, we can see that x equals 4 and y equals 3, so we can write OA equals 4, 3. We can also write it as a column vector, which is simply a 1 by 2 matrix. Magnitude of a vector is calculated using the Pythagorean theorem, a square equals b square plus c square. We can rearrange this equation to get the formula for the magnitude. Take this vector as an example. By applying the formula, we get magnitude of AB equals 5. Types of vectors. Parallel vectors are vectors with the same ratio. Ratio is calculated by dividing x by y. For example, these two vectors are parallel because their ratio is the same. Unit vectors, on the other hand, are vectors with magnitude equal to 1. These are solely used to represent direction. Position vectors are vectors that specify the location of a point relative to the origin, that is 0, 0. For example, point A with coordinates 3, 2 is defined by the vector OA, where O is the origin. Vector addition. Let's take two vectors AB and BC. The requirement to add these two vectors is that the head of the first vector must be equal to the tail of the second vector. The sum is equal to the tail of the first vector joined with the head of the second vector. Therefore, AB plus BC equals AC. We can visualize this concept by drawing the vectors to be added, in this case AB and BC. Then draw an arrow from the very start to the very end to get the vector for AC. The requirement for subtracting vectors is that the tails of both vectors must be same. The answer is found by writing together the head of the second vector first and the head of the first vector second. As you can see, subtracting OB from OA leaves us with BA. To solve this question, simply multiply both x and y by the scalars separately. 5 times 2 is 10, and 4 times 2 is 8. By applying a scalar, the vector becomes that times the size. In this case, its size doubles. This is it for this video. In the next video, we'll solve some exam-style questions to grasp a better understanding of vectors. Subscribe for more.